Hello, hello. Welcome back, everybody. I hope everyone's having a good day so far. Today is December the 27th, 2024. Today is a Friday. It's We're feeling good. We are streaming today, doing some Python. So let me get things loaded up here. Let me go ahead and get a message out to the Discord. All right. Cool. All right, now let me go ahead and pull up the chat on my phone here. Okay, view channel live. Awesome. We are pulled up here and we're good to go. Hey, Christy, welcome back. First one in here. How you doing? Mahan, hello. How you doing? Welcome back. It's great to hear from you. How you guys doing today? Welcome back in. I appreciate you guys joining me. We passed 600 subscribers on the channel today. Super awesome milestone. I am beyond ecstatic here. We are able to pass 600. The channel's really growing, just unbelievable. Really want to say thank you to you guys. You guys have been the key, support system in this channel, and I couldn't have done it here without you guys. Honestly, it's just truly incredible that you guys are supporting me. Hello, we got Edwards 404. Welcome. Hello, how you doing, Script Serpent? How you? Welcome back in. Dalet Ashirbai. Ashirbay. Hey, how's it going? I appreciate you. I don't think I've read your name in the chat yet, so I appreciate you leaving a message and coming in. Awesome, Christy. That's so great. I'm glad to hear. Yeah, hopefully 1K subs next month. That's a good goal. We're on track, and if we keep growing and progressing here, I think we should be able to meet that goal. So super exciting. But obviously, can't do it without you guys. You guys are you guys are truly amazing, and all the interaction I get here and everything. Thank you so much, Mahan. Okay, so let's go ahead and let's load up a new problem here. R6.6 keyed up high. Okay, now let's take this guy over, paste it here. I am a little bit tired today, guys. I'm not gonna lie. I'm a little bit worn out, so my brain I might not be as sharp as I was last night. I'm gonna try my best, but bear with me here. I'll probably need you guys' help throughout some of these problems. Just tired today for some reason. It's been a long weekend here. All right. So for this problem, for those that don't know, on the right side of my screen, we are reading aloud data structures and algorithms in Python. We are currently on page 272 of 770, so we have a lot to go, but cup half full. We have made a lot of progress so far. We are further than we were yesterday and the day before that, and so on and so forth. So little by little, we're going to get through this. And so we just completed chapter 6 a couple streams ago on stacks, queues, and decks. And now we're just completing some reinforcement problems at the end of the chapter to further solidify those concepts and give us a little bit more practice. I only really do the reinforcement problems. If I need a little bit more extra, I'll do a couple of the creatives, but I usually try to keep it to just the reinforcements because there's a lot of problems. We wouldn't be moving on at all if we did all of them. Okay, so we need to give a precise and complete definition of the concept of matching for grouping symbols in an arithmetic expression. Your definition may be recursive. So I know that I thought that they did this for us, like within this chapter. They're kind of asking us a question that was already answered in here. Right. Here. So this was an algorithm for matching delimiters. So this is what it was, this was the example that it gave in the book here. So it's kind of weird that they're asking us like kind of the same question, I guess, but yeah. Anyway, so an algorithm for matching delimiters, right? An important task from processing an arithmetic expression is to make sure their delimiting symbols match up correctly. Code fragment 6.4 presents a Python implementation of such an algorithm. A discussion of the code below as follow of the code below follows. So we have a function where it is matched and it takes in some expression. Mahan, I do not. I don't think YouTube allows links to be sent in the chat. So feel free to just to throw things in into the Discord, into like the general chat for like Python community, if it's Python related or whatnot. Yeah, the Discord would be a great place for that. I just don't think YouTube allows links in the chat. Okay, so is matched. We have a group of we have a string of all the lefty, delimiters, and we have a group of all the righty delimiters. We call some array stack, right, for s is equal to array stack. For every character in the expression provided in the function, if that character is in the lefty list, right, we're going to push that character onto the stack. If the character is in the righty, right, we're going to return false if there isn't anything in the stack, meaning that we didn't have a left delimiter if we come across the right one. But if the righty index of the character is not equal to the lefty index, right, we're going to go ahead and that's popped off. Okay. And then we're going to turn is empty if all the symbols matched. Okay, so give a precise and complete definition of the concept of matching for grouping symbols in an arithmetic expression. Your definition may be recursive. So you would, create a function that takes in some expression, right? We're going to establish a string of all lefty characters. We're going to establish a string of all the righty characters, right? We're going to create a stack. Iterate over every character in the expression provided. If a character is in the lefty group, lefty string group, append or push the character to the stack, right? If the character is in the righty string group, we're going to check if the stack is empty, no matching left character previously found. Okay, and then we'll say check if the stack is empty, no matching left characters, no matching lefty characters previously found. We'll say, we need to say lefty, look at the quotes here. Okay, then we're going to say check if the righty at index character. So we get the index of this value is not equal to lefty index.pop. Hey Tan May, welcome back in. It's awesome to hear from you. How you doing? Yeah, exactly. Stacks, parentheses matching, that's what we're kind of working on right here. So for the character, we get the index of that character in the righty group here. If that's not equal to the index that's popped off, right, because the matching symbol is at the equivalent index point. Okay, so we're matching index points in these two groups, and this is what was popped off of the stack when we found, okay, an element. Okay, check if the index value the character is lefty index, lefty group, of stack.pop, right? Like that. And this one was kind of more like theoretical, coming up with this like precise definition, kind of like a trace or something. I'm not sure if I'm doing this really correctly, because it's more like open for interpretation, and so if you guys have anything to add, let me know here. But I think I'm gonna move on from this one from here. It's they already established this function here. They're just kind of asking us to, I think, go back and kind of make sure we understand this. So yeah, let me know what you guys think. Okay, let's kind of move on here. Okay, R 6.7 underscore key dot pi. Okay, and let's take this guy. Okay, I like these ones. These ones don't look that hard, aren't that hard. Okay. So we need to, let me fix the formatting on this. Okay, like so. What values are returned during the following sequence of Q operations? So if we have some Q is equal to an empty list, you're using recursion though. So yeah, it says it may be recursion. So it says it's a possibility that we can use it here. So I don't think it needs to be a definitive answer in recursion. Okay, so okay, we have an empty queue, right? So we know that queues are like lines where the last person into the line is the last person that is then removed from the line. It's first in, first out. So knowing that, we have a queue which is first in, first out. So our first operation is NQ5. So we're going to add to our queue the value of 5. Okay, we're going to NQ the value of 3. Ooh, whoops. So now with queues, this is where I kind of ran into trouble. I brought up some questions. Does the queue start? Is the end of the line the append, and we are removing indexes at the start at 0? Or that's my question. So if we NQ3 here, is the end of the line at index value -1, right? Is the end of the queue at index value -1, right? or is this the start? Now, I know that when dealing with that, we'll have to take into account, time complexities as well, because the amortized, appending at the end would be constant time, but if we had to remove every item at index value 0 and subsequently shift items down. Now, if we were using a circular queue, that's where we wouldn't have to really manage that. We'd have to manage a like a placeholder almost, right? Um, of like an index holder of where our current first value is. All right. Script, have you heard of Kali and Black Arch Linux? No, I have not. Hey, Angela Lopez, welcome in. 6 months, yeah. Yes, that's so awesome. I'm so happy that we crossed that milestone today. It's really awesome. Thank you guys so much. Mohammed Al Ghini says, sorry for the random question, but what are your thoughts on recursions? Did it stick easily for you? No, I would probably say so far in the book, the hardest concept I've had to learn was the recursions. Um, I would say that out of these 6 chapters so far, the most difficult, like grinding through, was probably just some of the grinding through of like the deep stuff in the Python review. But the recursions, if you go back to those streams, we really struggled through understanding, and chat was like constantly having to refresh and remind me that, oh no, you need to call the function again, you need to return these values. We did a problem yesterday with recursion, and I'm still gaining familiarity with it. So I wouldn't say that great at them right now currently. So we're still gaining that practice. But recursions was definitely the hardest aspect so far. I think we've had to learn in this book. Um, Besides maybe like time complexity, just understanding those functions and how they work. But once I kind of remembered my calculus and my pre-calculus, it kind of came quicker. But recursions was something that was just blind, like I'd never seen before, really. So yeah, it was definitely harder. So if it's giving you trouble, don't be discouraged. I was right there with you. I am right there with you, right? Okay, so if we NQ5 and NQ3, and then we DQ a value, this is going to remove 5 from our list, right? Ooh, whoops. So we NQ3 and we DQ5, right? So 5 would be removed, and now do we have a value of none here? Like this would be with using a circular queue, right? We would provide a value of none here. Let's keep going. So we DQ'd, we're going to NQ2. Okay. We're going to NQ8. Ooh, whoops. 8 gets added to the queue. We're going to DQ a value of 3. Right. We're going to DQ another value for 2. Hey, Alex Lee, thanks so much for leaving a message. Hey, Jeremy, welcome back. I appreciate you. Wow, 600. Yeah, we're climbing up there. Awesome. I am so, overwhelmed, and I'm so grateful for that milestone we crossed today. Thank you guys so much for your support. Alex Lee asked, "What are you using to learn?" Yeah, so I first started off with Harvard CS50P. Was my first ever, look at programming and any lines of code at all. And then once I completed that course, I just started reading, textbooks to continue my learning. So I then did a Python crash course by Eric Maths to, fill in those gaps left by Harvard CS50P. And then I started creating some independent projects to help, reinforce those concepts I learned. And then now we're working on data structures and algorithms in Python and reading this book aloud, audiobook style, live on stream, and then working on these practice problems. So I mainly teach myself out of books so far. My philosophy is if you really think about it, um, right, all college is just a reiteration or a verbal, um, like demonstration or whatever of these already written texts, right? If you go into any college class, they're probably going to have you or recommend that you buy the book. Well, everything that is in the class is in the book. So why, just bypass the middleman and let's just get the book, right? Mahan asks, why do you put none just for yourself as a placeholder? Yeah, so that's what I was wondering. I was thinking about as well. So in our example above, we were given an array Q class that instead of using a you know um, how can I do this? Instead of having a queue that can dynamically change, n number of times for all the operations that happen, if the operations are m or n, whatever, it gave this example of a circular queue with a default capacity, right? And if the default capacity gets to the point where we need to expand, well, we will go ahead and expand the queue larger by probably double the default capacity if we end up needing more spaces. But the whole idea behind this default capacity queue that it gave us this example of was that it was circular, right? We're using a circular array. So by having a definitive value, so I guess we would have to kind of say that this would look something like this. If this is our queue, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? So we have 10 default none values in our queue. So knowing that, let's go back here. So I'm going to make a note here saying using the circular array queue concept. So we have some queue that has a initial capacity of 10 values. Right? If we wanted to go ahead and duplicate this down and say we're going to, let's go down to our program over here. Sorry. We have NQ5, so we're going to replace the first value with 5. Okay? Or whoops, sorry, down here. Right? Our next is NQ3, so 3 will take the place of the next placeholder in the queue. And we're going to dequeue the 5. So now the 5 comes off, gets replaced with none, right? And so our array doesn't dynamically change anymore in memory, and so we are constantly saving this, just overwriting these values and circularly. So now our first value is at index value 1, right? All right. So then let's see here. If we NQ'd 3, we DQ'd, now we need to NQ 2. Let's copy this down. We're going to NQ 2 to the next spot in the queue. We're going to NQ 8. So let's NQ 8 here. Let's go down. We're going to DQ twice in a row. So this is going to DQ the 3. And this is going to DQ the 2. So now our first value, our first next spot in our queue is at index value 1, 0, 1, 2, 3. Right? So now we have NQ9. We have NQ1. We have DQ, which will take care of which will remove the 8. 9, 1, DQ, NQ7. Right there. Then we're going to NQ6. Cool. We're going to DQ twice in a row. So this is going to take out the 9. This is going to take out the 1. And we're going to NQ4. Okay, we're going to DQ twice in a row. Oh. Oh, see, I think I'm getting messed up here. Okay, hold on. Let's make sure we have this correct. So, NQ5 is our first operation. So we have our default value here. We add 5. We NQ3. We DQ the 5. We NQ2. Right, perfect. We NQ8. We DQ the 3. See, I'm getting all mixed up here. Hold on, you guys, I'm sorry. It's just getting super jumbled. I need to go back. Okay. So I'm just going to copy this over, like so. Oh, no, whoops. Control C. Okay, so we're going to NQ5 at our first place. I guess we'll say NQ5. Okay, let's copy these down. Okay, we're going to NQ3. Okay, let's copy these down. Oops. Oh, this is so frustrating. I get so jumbled here. It's just so easy to get disorganized with this type of formatting. Okay, so we NQ5, we NQ3, and now we're going to DQ. So this is going to remove the 5. We're going to NQ2. This is so annoying. It's getting really warm in here. It's getting real hot in here. Gotta, whew. Okay. Bring that pillow back though. Okay. Sorry, you guys. It's like I said. I'm still at my parents' house, visiting them for the holidays. So. Hey, Wing Hong, welcome in. Appreciate you joining in. It's awesome to hear from you today. Hope you're doing well. Okay. This is getting annoying. So we NQ3, we DQ the 5. We're going to NQ the 2. So here we get a 2 value. We're going to take this. We're going to NQ 8. So 8 goes here. We're going to DQ twice in a row. So this is going to remove the 3. We're going to do this one more time and remove the 2. Okay, so now we just have the 8 in there. We're going to NQ 9 and 1. So 9, NQ 9. Let's take this, NQ1. Okay, what's next after that? 9 and 1. We're going to DQ once, NQ7. DQ. So this is going to get rid of the 8. Oh, come on. Okay, we DQ once, and then we NQ a 7. NQ a 7. Um, NQ is 6. Here. Okay. We DQ twice. So this would be none. This is DQ. All right, we do this twice. One more time. We DQ with 1. We NQ4 and DQ twice. Ooh. NQ4, right? And then we take this and we're going to DQ twice, just leaving the 4. Right, and then one more time, DQ'd out the here, so we should be left with that. So if we go back up and we add up the NQs, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 NQs, and we call how many DQs? 1, 2, 3, 4, 5, 6, 7, 8. Perfect. So we should have one value remaining in our array, which we do here, in our queue, which is 4 at index value 9. Awesome. All right, it's cool. That is that one. That was kind of long and annoying, guys. Sorry about that one. All right, let's keep moving here. Our 6 point. Let's go down. You know, I'm sorry. It's a little bit more cramped for me. I'm on a single monitor here on my laptop screen, so just bear with me, guys. I'm trying my best here. Sorry, I'm visiting my folks for Christmas and the holiday break here. I will be back in my normal setup for the stream on this upcoming Sunday, the 29th, though. I'll be back in my normal setup the 29th. So Sunday night we'll do a stream when I get back, and it'll be all normal again. Okay, so 6.8 underscore key dot pi. All right, and let's get this one going. Sorry if I keep moving this monitor back. I have a hard time getting comfortable. Okay, 6.8 here. Okay, this one says, okay, suppose an initially empty queue has executed a total of 32 NQ operations. Okay, so we've appended or NQ 32 elements into the queue. 10 first operations. So we did 10 first operations, which are references to the first value in the queue. Does not remove the value, right? So this is just a reference, so no append or removal is happening to the queue with this operation, so we can ignore that. That's just a fluff to kind of trip us up. We have 15 DQ operations, 5 of which cause empty errors. So we have 15 DQ operations, 5 resulted in empty errors, right? So this would result in 15 minus 5 equals to 10 DQ successful DQ operations. So in total, it would just be 32 minus 10, 32 NQ upper unq minus 10 DQ operations equals to um, a remaining of 22 elements in the queue. We'll say length queue or queue dot underscore size is equal to 22, right? Because when we're dealing with queues, we have a size element because the length of the queue is that fixed circular aspect that we talked about above. All right, let's see here. I use my iPad when I'm at the library. Do you have an iPad? It's life-saving. No, I don't. I actually I've been maybe considering getting one. I do like to draw, like as a hobby. I like to I'm picking up hobbies like crazy here, but I do like to draw and I make these little graphics for the channel and the thumbnails, like the little Python crash course guy I drew out and made, and the little sword and stuff that he has. So I am considering maybe getting an iPad for that so I can use like Procreate and draw and stuff, which would be really cool. Um, but how do you use it for programming? Do you use it just to have an additional screen, or how does it do you have any examples of how it makes things easier? I'd love to hear that. Script Circuit says, I'm currently using Black Arch trying to check for vulnerabilities in a system that I can find, hopefully. Oh, awesome. That sounds really interesting. Is first like top for a stack? Yes, I believe so. It's that, right? It's a reference to the element that's next up in the queue to be removed or dequeued, but it doesn't actually remove it. It just references it. Use it as a second monitor. Oh, got you. Edwards 404 says, I think this is Q equals NQ minus DQ valids. Exactly. Exactly right, Edwards. Thank you so much for your comment. Appreciate you. Perfect. So glad that we're all on the same track and on the same page here together. Also, mind map and extra brain storage. I bet you, like, if I got an iPad, I'd have to figure out how I could also capture the iPad screen with my OBS. I'd have to, it might get pretty elaborate here. Become a whole streaming setup would be kind of crazy. But we're at 600 subs streaming, so, the channel is growing just based off of my streams alone, pretty much. So if that's what it needs to keep it going and improving, then that's what it needs, I guess. So I'll definitely take that into consideration if there's any deals that come up, or maybe I'll wait for the next generation to come out and I'll pick up the one previous of it. Okay, let's go ahead and try the next problem here. Good job, you guys. We got through this one. Oh, we need to change the name, add an R at the beginning. There we go. Alex Lee says, would you recommend Java or Python to starting to learn about DSA? I can only provide my personal input, and I only have experience writing in Python. I do know a little bit of HTML, just the basics. I do know a little bit of CSS, just the basics, to create simple front end websites. But I only put in a few hours of practice in the Odin project, and I shift back over to Python. I'm a scientist. I'm a formulation chemist. For those that don't know, I graduated back in 2021 with a Bachelor of Science in Human Biology and a minor in Chemistry. I worked as a formulation chemist right now for a biotech company, and I'm currently a mid-level scientist too. I chose Python for me personally because I know that for what I've read and did research on it is it's great at handling data and in analyzing data. So maybe just take that into consideration, and consider your current needs and your current field and passion and stuff. But maybe if someone else has some other input, I think some other people are commenting to you here right now. Both kind of the same as both our OP languages, object-oriented programming languages, but go Python if you're new, it is easier. Seems like online people say Python because it's much less verbose and easy to read. Yeah. I often feel that maybe beginners too. I think a lot of times the same questions keep coming up over and over again. Oh, what language should I learn? I don't know what to build. I'm staring at the code, and I've learned. I took a course, and I'm staring at the terminal, and I don't know what to do. Um, you know, I think it's. it's just easy to, you do have to be creative, right? If you think about it, some colleges, the computer science degree is a Bachelor of Arts degree. It's in the arts category because writing this language and using these language, you have to be creative to come up with solutions and ideas, because at the end of the day, it is all on you and your ability to convey these thoughts into code. So don't get tripped up on the trivial things of like, oh, what language should I learn? And because I often feel that, especially for beginners like myself, or I've had talked to other friends that maybe were interested in programming and have come to me maybe for a little bit of advice. They constantly just say, I don't really know what to language on, I can't decide. And that seems to be the main factor that is holding them up from actually even starting. So, which is just really inefficient, because if you're just getting stuck on what language to start, then it's just going to be a rough road ahead, in my opinion. So just really just pick one and go for it. If you end up not really liking it, there's no stopping you into being able to try something else. But don't get tripped up on the trivial things about, oh, I'm not sure if I should choose this or that. Just dive in head first. You're not going to learn to swim unless you actually jump in the pool. But use this channel maybe to gain it from a beginner perspective. That's what I wanted it to convey when I was researching and trying to understand, or find methods and resources to use. I often found that a lot of the people, streaming or providing the information were really advanced, and so it was hard for them to convey things in a beginner point of view. They really used a lot of jargon that they already established in their just their knowledge and things, and that's not their fault. They just kind of became a little out of touch with what it was truly like to come at this from a beginner's point of view. So I wanted to provide that just by streaming and literally just recording me going through these raw and just trying to plug and chug and try them out over and over, because in reality I think that that is what is learning is truly is. It's just this raw attempt at trying things over and over again until we get it right. And the current way things are conveyed, it seems like, oh, it's kind of like a get done quick, and you can get paid X money, and it's just not really the reality of things, in my opinion. Edwards 404 says, I agree, Michael, understanding the concepts and fundamentals over choosing languages. Yes, exactly. So that's why I've specifically kind of focused on, not expanding outwards to other languages right now, because I don't really need to. I'm trying to understand computer science topics, and each language is going to convey those computer science topics for the most part. Obviously, some have other implementations than others, but to their core, we can do a majority of everything in just one language. And so once we have that mastery, then we can go and step and expand our tool set, for lack of a better word, and it'll be that much easier to move on to other languages because we have this current backing. Okay, enough of my ramble. Sorry about that, but I really appreciate your question. Thanks so much for commenting and joining the stream. I really appreciate you coming in. We have a lot of great people in here that give a lot of great advice. So just yeah, thanks for joining the community. If you guys are interested, I have a Discord where I made linked below, where I have compiled all of my study resources, and I'm going to be hosting some events, to or promote events when I stream for completing the next CS50 course we're going to do coming in 2025. So follow along and join the Discord for that as well. It's going to be really awesome. We're going to complete it as a channel and as a group here. So you might as well, if you're going to be watching the stream and watching me complete the course, you might as well sign up for it as well, completely free, and submit the problems as well so you can get the credit too. It'll only help you, I think, right? Okay, so let's do 6-9 here. Had the queue from the previous problem be an instance of the array queue that was used with that used an initial array capacity of 30 and had its size never been greater than 30, what would the final value of the front instance variable? Okay. So if we had a queue with a size capacity q dot underscore size is right, so the q, sorry, let's go like this, q dot underscore size. So this variable tracks the q variable, or the size variable, not the length, because the length has that fixed value. So actually it would be Q length the length of Q would equal to 30, right? So the length of the Q would equal to 30, but the size would be equal to the actual elements that are filled into those none placeholders. So had the Q from the previous problem been an instance of the array Q class that was used at an initial array capacity of 30, had its size never been greater than 30, what would be the final value of the underscore front instance variable? So if we did 32 NQ operations, but we never exceeded the length of 30. So our queue never had to update its size greater than 30, the initial capacity set of length. So we have to figure out, so if we were to, like, we have 5 error operations for the DQ. So if we were to queue, DQ, that would cut off one of these. So let's just say for this example, let's say we call these 5 unsuccessful DQs at the very beginning before we even NQ. So those get called at the very beginning. We then call if we call, let's say, 15 NQ operations, let's cut it in half. We'll say 16 NQ operations, and we did 10 or 15 DQs off of those 15. That would leave one value and 16 more, so 17 in there. The front instance variable would resemble this is making me think. So that removed, thus the index so if we had 32 successful Q operations and 10 successful DQs, that means we have 22 elements in the array. So the length would be 22 elements are left in the array from, so it would be, right, if 22 elements are left in the array, then it would be 30 minus 22 would give us 8. So we have 8 none values that are ahead, that are preceding all of our current values in the queue. So if we have 8 values, so the 0, 1, 2, up to 7, so the 8th index is going to be where your first is going to lie, right? Or your front instance variable. What would be the final value of the front instance variable? So front, does that give, yeah, front gives us an index value back. So would this be at index value 8? Q dot underscore front is equal to 8. What do you guys think about that? This one's kind of tricky. So if our original length of the queue is 30, that does not change. We have 10 successful operations for dequeuing and we have 32 operations for NQ that were successful. So we called 22, that means we have 22 elements that remain in the list. We DQ'd the first 10 elements off of the list. Okay, I'm trying. So if we have a length of 30, 30 values of none, we keep the first 10 slots are going to be none because we DQ'd 10 times. So 10 slots are going to be none. And we have 22 items left in the queue. So the first 10 cannot be none because then we would be over the value of the queue, of the length of the queue. If we had 10 slots and 22 values, well, that's 32. So no, that would not work. So this, what it's referencing, if you guys aren't, so the front operation, right? The front instance variable. Oh, and these first operations. So if we go back to our queue, the first operation is a reference to the first most value. So it doesn't actually remove anything from the queue. So if we had 32 NQs that were successful and we removed 10 of them, that means there's 22 elements in our queue at what point? So we have to determine where in the index is the first value. Well, if the DQ happens at index value 0, 4, and then onward, as the front changes, then I think it would be 8, no? Now, what if it wrapped, though? So we added like 10 items, we DQ'd off 10, and then we added in 22 more, right? So there would be 10 slots that are empty ahead of it. But it wraps circularly. So if 11th is the starting index, no, 10, if 10 is the starting index, right, because we're 0 indexed, then we'd have 22 items. So it would wrap and we'd have filled in values for indexes 0 and 1 if we started at index 10. Let's go ahead. Um, are the values from R67 or yeah, so we're trying to so no, we're it's independent of that. It's 6, 8 and 6, 9 are kind of working together here. So it's not 6, 7, but I'll go back up to this queue operation, this function, right? So the array queue has um, a front operation, right? That just keeps track of the index value of our front placeholder. Yeah, some of the array queue from the previous question, Wing Hong. So the thing is though is our queue never exceeds capacity. So it never calls a dynamic increase. So, we have a bunch of scenarios that would work for though, right? Like if we added, right, we pushed, we NQ, um, like 10, or we NQ 15, right? That means that we have 17 NQs remaining, right? And then we add 10 DQs that were successful. So leaving 5 elements in the remaining. So plus 17. So that'd be 5 plus 17, 23. And so that would be applicable as well. Kai Johnson asks, are there online models and programs we can plug in the numbers to visualize better? I'm not sure. I'm sorry, I'm not helpful in that front. When you use NQ a number into an array queue of size 30, which index does it stop at? See, it would assign it to the ooh, sorry if you hear my mom's dogs barking in the background. Oh my gosh, they are really barking. I apologize if you hear them. Sorry, guys. Okay, let's go back to the question here. Here. So 6.8 says, suppose initially empty array Q has executed a total of 32 NQs, 10 first operations, 15 DQs, and 5 of which were empty errors were caught and ignored. What is the size? Well, the size of this would be 22. We had 10 successful DQs and 32 successful Qs, which means that 22 items remain in our array, or our Q array, right? But what value or what index value is the first value when we have a capacity of 30 initially and it's never been greater than 30? So we didn't do all of these Qs at the same time. So then what is the trigger for sizing up? The trigger for resize is if cap is greater than the length of self. Hmm. Um, so you've done a bunch of NQ and DQ operations and the Q never exceeds the size of 30. Initially, front starts at 0. Each DQ increments front by 1. So you've done 17 DQ operations in total, right? Yeah, each DQ operation increments front by 1. So front was initially 0. I feel like this has so many possibilities though, because you can mess around with these NQs in various factors of 22 or whatever, of not factors but addition and subtraction factors, for we'll say, and like for the 15 and the 17 they get to 32. So I feel like you can mess around with any of these at any point. So you could say like this is, if I did 10 here, which would take out 10 DQs, right? If we did, and so that would be, the front would be index value 10. So would the front be at index value? The front would be at index value 10 here, because that would be the next front. Yeah, so if we do 10 NQs and then DQ 10 times, right? For our 10 successful DQs, we have 0 items in the remaining in our element, right? And then we had 17 more NQs on top of that. So at this point, our front would be at index value 9, right? Once we did these DQs, our front would then be at index value 10. If we did 17 NQs off of 10, our front would be at index value 10, because 0 through 9 were reserved for these values, and the start would be at index value 10 for the next 17 values. Looks like we got a lot of people thinking about this one. I appreciate you guys and your help on this one. Um, is it in order? I don't know. This is all we've been given. So you can't call 32 NQ operations, right, in a row for this problem, because that would cause the size capacity to increase, right? We would be greater than the set initial size of the array of 30. So you have to do a split of these NQs somewhere. And what I'm saying is we could change this to be 15, and this could be, what is it? Or 32 minus what, 17, right? Or this could be, we could change these values for any sort of addition factors of 32, and it would kind of give us a different start value each time. Yeah, that's what I was thinking, Mahan. It has to be like about indices 10 through 15, depending on how many initial items you first DQ'd. So but think about this, if we had D, five initial, you could have called those 5 DQs on an empty array, right? But let's just think about it like this. We have to, if we want to bake in those 5 um, unsuccessful DQs just somewhere rather than it being at the start, well, we can use this example where we NQ 15 items, we DQ off 15, or we DQ off, no, we have to add 10 items, DQ 15, right? 5 of these will be unsuccessful, and then remaining we have 0. So this is just the absolute value, of a positive. So we're not, doing this negative operation. Um, Not absolute value, but some of the of what it is, but positive, right? Plus 17. So for this example, we would have 10 Qs. So our first would start at 0. We would DQ off 15 times. So our first would go to 2, would go to 3, go 4, 5, all the way to 9, right? And then if we NQ'd, so it'd be 10. The front would be at index value 10, I believe. This is interesting. Or 0 base 9 through 14, yeah. Nugs asks, hey Nugs, I appreciate you coming in. He asks, how is the array queue implemented? What happens when when an NQ an item at capacity? When you when I think what it does is it doubles the size of the queue. But in this example, we never meet capacity, so we're splitting these NQs, apart in between with a DQs in the middle somehow in some variation. But there's just multiple ways we could do it. It seems like. So the resize happens, the old is the data. Um, we multiply it by the cap, create a new data list with none as cap times cap, and then we walk up and save all those values into the new array. Hmm. J Torres, 1800. How does the array queue initialize the array? Yeah, so it would be just initialized with a given data size of a default capacity, and this example is a default capacity of 30. So, but it's also important that we never dynamically increase. So that's why we're having these DQ operations happen in between because we don't do 32 straight NQs, or else we would have a dynamic increase in queue size. Yeah, this question is pretty word. People are saying that this question is pretty worded, is worded pretty vaguely and is not that intuitive. It's not a good question. So the authors need to maybe revisit this one in their next pass through this book. I kind of want to throw it to the Almighty Orb and see what it says. Okay. So let's give it the exact number of NQ operations and DQ operations. Here are the operations. And we'll say I am having trouble because there are many different combinations which you could NQ a portion of the 32 NQs, call the 10 successful DQs, and then the rest of the NQs. You could start with 10 NQs. You could start with, right, we can't do greater than the array size. So you could start with 10 to 15 NQs, something along those lines. Let's analyze the problem step by step to determine the current size of the queue. The key is to carefully track the effective operations of the queue state. 32 NQ operations, each NQ adds one element to the queue. 10 first operations, first retrieves the element at the front of the queue but does not modify the queue, it has no effect on the size. 15 DQ operations, of which 5 reported in errors, so only 10 of them were successful. Key observations. Since the queue starts empty, all elements in the sequence must come from the 32 NQ operations. Of the 15 DQ attempts, only 10 were successful, meaning 5 were ignored. So elements to add. From 32 NQs, the total elements were 32. From 10, it says 22 elements. This operation involving first, the current size of the queue is 22. The operations involving first and the ignored empty operations do not affect this calculation. Yes, okay. So now we'll ask it this one. Given that there are 22 elements, to determine the final value of the front instance variable, let's carefully track the sequence of operations, how the front changes in a circular array implementation. So the queue starts at front equals 0. After 32 operations in 10, we have 22 elements. The current front depends on the number of successful DQs. So the initial front starts at 0. We have 10. So the 10 successful DQ, the front is at index 10. Okay, we got it right. Woo! The final value of the front is variable 10. Wow, we were right. Awesome. So that's crazy. Awesome. Yeah, so it should be 22 regardless of the order, exactly. So that's why I initially came up with this 10, is because you're going to have 32 minus 22 with an index of 10 for the next value. So I guess it only depends on the amount of DQs if you start at a index value of 0 for a front. So your front equals to the number of DQs. in this case. So you'd say like q dot underscore front is equal to the number of total successful uh, DQs, right? Like so. Successful DQ. Okay. Okay, so I think some people are lost in this one. Let's go back. I have a lot of comments here. I was thinking about this and okay. Um, yeah, Nug says, I feel like it's trying to test if you understand how a queue works, but it doesn't even say how the operations are processed. Are you trying for a circular queue implementation? Yes, Kai Johnson. That's exactly what we're doing. Mahan says, give it a last queue also. Fake says, "Hey, can you tell us what you're doing?" Yeah. So for those that are new and just hopped into the stream, my name is Michael. I graduated in 2021 with a degree in human biology and a minor in chemistry. I work as a formulation chemist for the past 3 years. I'm currently a mid-level scientist too, a chemist for a biotech company where I make biological controls used in diagnosing patients and clinical testing and things like that. For testing validity and verification. I I am learning Python just to further improve on my skills, further increase my education. I'm live streaming this to also show you guys like from a raw beginner perspective because I'm not a CS student. I'm teaching myself this just out of my own drive and willingness to learn. And so I've been reading out of these books and really just holding myself accountable. And it seems to other people really enjoy the format of a beginner's point of view because they might be in a similar situation or they just like to have the camaraderie and companionship of studying together, or maybe they just like to have the inspiration that if I'm studying, that they can then, oh, he's studying, then I'm going to study too. I've had some people also say that they use it for that purpose. So currently, I started about 6 months ago. I've made a few projects, which I'm quite proud of. I started with Harvard CS50P, and I've been just reading books ever since. We read all of Python Crash Course live on stream and completed the problems. I'm going back through and uploading videos to my channel for solutions to those try-it-yourself problems they're just easy, Python practice problems for learning the syntax and things like that. So for the beginners out there, like myself, but even the more beginners, more recent beginners, I've been providing those solutions to the channel, as well as just continuing my own education further. So I'm reading now data structures and algorithms in Python. You can find this online, or you can join my Discord link below, where I provide all my study resources for free, no charge ever, would never charge for that. I am a learner, I'm educating myself, I'm not an expert in this, so it would be completely unethical to charge any sort of fees for this because I'm learning myself. I want this to be a peer-to-peer environment where we are, um, what would it be, like colleagues, learning this together in a similar situation. So, yeah, hopefully that sounds like something you're interested in. So, feel free to join along. All right. Yeah, so Nug says, now I think 6.8 will always have the same answer regardless of the order. No, yes, it will always have the same answer regardless of the order, of 22 being the length of the size of the queue. Um, now the length of the queue in a circular array or a circular queue has that fixed capacity. So we use the underscore size method when in our actual array class above. It's hard to keep flipping back. I'm sorry, you guys. Okay, so Wing Hong asked if I can explain. So let me give this a quick explanation. So in our previous problem of 6-8, or 6.8, we did a total of 32 NQs, which means we added 32 elements to the queue. We had 10 first operations. So a first operation in a queue is just a reference to the objects that is next up to be removed, right? So think of a queue as like a line for an amusement park or a line for lunch or something like that, where the first person in the line is the first person out of the line. So we have 10 successful first operations, which just says, oh, Mike is at the front of the line, but Mike is not removed from the front of the line within these operations, okay? Then we have 15 DQ operations, 5 of which were unsuccessful and raised errors because our queue was already empty. So That being said, 32 minus the 10 successful DQs would give us a total of 22 elements at any point within this queue. Now, the order does not matter because all it depends on is the number of successful NQs and the number of successful DQs, right? Those added together, where the DQs are negative. Now in 6.9, it's asking us, okay, now if we take that same terminology in 6.8, but we infer that the initial array has a capacity of size 30, and it never fills up to the point where it needs to expand past 30 with that dynamic, array increasing that we learned about in this chapter, um, or in the previous chapter, I believe. Was it chapter 6 or 5 that we learned about? Um, yeah, so array-based sequences are back in chapter 5. Um, so, right, if we exceed the capacity of the queue, we call a dynamic increase in the memory to then, append those references back into the new dynamically increased queue size. Now, given that we have a 30 that is never met at capacity, we know that we're going to have a length of the queue of 30, but the size of the queue, right, the queue dot underscore size is equal to 22, like we said in the previous example. Now we know that we had a total of 32 successful queues and 10 successful DQs. So what I've kind of come up with here is that the front value is the number of total successful DQs. That's kind of like a little hack that I think that we can use to kind of define this at any point, where the total number of successful DQs, as long as this, right, we need a preface here, as long as the queue never resized greater than original capacity, right? That is a caveat we need to keep in mind. So the front of the queue would just be equal to the total number of DQs. For example, let's say, because we cannot perform all 32 NQs at once, that will cause our capacity at 30 to be met, and we'll have to increase. So we can infer that that 32 does not happen sequentially all at once. That needs to be broken up, and the DQs have to take place in between to remove elements. So by doing that, I just did some practice ones, and we were able to infer that, let's just say that we started with 10 elements. We DQ'd 15 times, right? Well, the 5 of these DQs were unsuccessful, which we're showing that here because 10 minus 15 is -5. So, but we can't go into a negative value of the queue, so we just have 0 elements in the queue. And then we would add 17 more elements to the queue. But, so our front would be at the point at which our total number of NQs, or I'm kind of going back and forth. I'm doing a pretty poor job of explaining this, in my opinion, but I'm really trying my best. I'm sorry, you guys, but right, if we appended 10 items, we removed them all, but we have an array here. We add 10 items, and we remove them all. But our start is still at that 10. So, and then we add 17 more items, but our start is still at that 10. We haven't done any more DQs. So that's how my thinking was coming from for this answer. We have an array, we add 10 elements, we remove all 10, but our front still remains at that next spot because we have a circular array, a circular queue. And so then we add 17 more elements, but that front is still 10. It's first in, first out, right? Hopefully that visually. Now let me see if I can do it on a whiteboard. That might help. So we have our queue. We're going to add in, I'm just going to do like X's. So I'm going to do 1, 2, sorry, I'm using my trackpad here, you guys. 4, 5, 6, 7, 8, 9, and 10, right? So we added these elements, and they just by coincidence resemble their indexes plus 1. So, right, so this would have an index value of 9 right here, right? And this would have an index value of 0. So we add 10 elements to the queue, right? We then remove 10 elements from the queue. So our front would be here. This is our front. We add 10 elements to the queue. We then remove 10 elements, so our front keeps changing 1 over as we remove elements. So our front would end up at 9 here, and then we remove this element, so our front would go 1 more to 10 right here at index value 10 would be the next placeholder to add another value. So we would add a value here of like whatever, and then we'd add, 16 more values to the right of this, right? This would be 16 more values. But our front still remains at index value 10 here. Hopefully that visualization helped a little bit. Okay, let me get caught up on chats. I'm way behind here. I'm sorry, you guys. Won't the first operation throw an error? Yeah, but the errors are handled silently in this problem, it says, right? The errors are caught and ignored. They should clarify that the front points to the index in the array, not the value in the element. Yeah, they do, Nug. They do preface that just in the text above when they actually initialize this Q array. They do give you a little bit of a description of what's going on here, but we read this a couple of days ago, so that's just, I think maybe we're just kind of missing some information for those that are just joining today. But I appreciate you guys being here nonetheless. Thank you so much for coming in and participating. It's really awesome having you guys here. But yes, they did give some details, so feel free, if you're not following this, join the Discord and get access to this PDF. Take a look at page 243, where the array class Q is, and you can get an example of what it's doing here. It tells you what's going on. So it does tell you that the front is a reference to the index value, not the element within this text here. Okay. Let's go back here. Oh, front returns index. Yes, given the answer. Yes, wait, no, perfect. He's trying to understand NQ operations for circular Q implementation. Use something general like that. Exactly. Hey, KKR. Good luck, homie. You got this. Thank you so much for the kind words. I appreciate you stopping in. You guys are really great. Corey Collins. Hey, how's it going? I appreciate you coming in. Happy that you're streaming this process. You've got this. Oh, thanks so much. Yeah, I'm really trying to capture a beginner's point of view here. I do have experience, in STEM and science. I'm a chemist for my profession, but I'm a beginner programmer and I'm learning these all for the first time. So I really wanted to demonstrate what it was like for a beginner, with some collegiate knowledge in the past to, try this out for himself and what it really looks like to have to grind through these. And it's not all, rainbows and butterflies all the time, right? Nug says, if you have a decent background with proof/maths from your chem degree, I would recommend the book Introduction to Algorithms by Thomas H. Corman for DSA in general. It's more theory heavy, but explains the concepts pretty strong in my opinion. Yeah, I might need to check that out for sure. Thank you, Nugs. Do you mind if you're in the Discord, do you mind throwing a link, in the general chat or in the off topic or something, or maybe just copying that title over so I can see it again later on. I appreciate that suggestion. Thank you so much. DQs always remove elements at index 0. No, the DQs always remove that next element at the first plate at the front, right? So the DQ would happen at the front index in a circular queue. Short and Sweet Tube again. Hey, how's it going? Welcome. I appreciate you. I like your name. That's a funny name. Sarah Vita. Vitia, I appreciate you coming in. Hopefully I said your last name right. I apologize, but thank you, Sarah, for coming in. Yeah, so Mahan has made a good point here, like we brought up earlier, is that the 10 to 15, right, about being that the front could be anywhere from about 10 to 15. Like, what if we called the Well, I think it wouldn't really matter if you called the 5 initially or the 5 here, right? Because you would still have to NQ and DQ those successful 10 DQs. So I don't think actually or Mahan, I don't think whether you have the 5 unsuccessful DQs here or you have the 5 unsuccessful DQs at the front, um, it it really depends on the 10 successful DQs is equal to the front. Right. Wing Hong says, wait, shouldn't front always be at index zero? So front does get overrode to index zero when we dynamically increase the size of the queue, but um, front is updated when, because remember this is a circular queue. We're not going to completely just increase the size of the queue over and over and over again and just have a ton of none values that precede all of those, those already DQ'd elements. That would just cause a ton of space to be taken up within the memory eventually, right? With a large number of n elements. So we use a circular array approach to fill in those already DQ'd placeholders, right? Think of the array as a like just having slots or like a shelf, right? Where you can put items in the queue and then remove them and then refill in those shelves. You have a fixed amount of shelves, and then and if you get to a point where you need to dynamically increase, you can, but in this example we weren't, right? Hey, Copter, welcome in. And it's been a while since I read your name. I appreciate you stopping in, and it's so awesome to hear from you. What's going on? First slash front slash head is the first item of a queue that is to be popped. Last end slash tail is the last to be popped, not the list index. We don't care about it. Yeah. How would you know what front gives you? Right. So front, remember, front is not giving you a value. It's not giving you the reference to the element. That's what that call to first was, right? The function first or the method first. Um, where was it at? I'm sorry, we lost here. Yeah, the 10 first operations are just references to those first objects. The front, right, just returns the index placeholder at where the next value that is going to be DQ'd will reside. It is, think of, these are physical places in the queue. The queue does not care, like a key concept that we learned when we were in chapter 5, when we were starting to get introduced into these array data structures, is that the actual references and elements inside the array do not matter. They do not impact the size of the overall array in memory. Those elements are stored elsewhere in the system's memory and then are just applied references inside the array. The array, how it's determined with its capacity, is just if you have slots. So let's say you have an original array with 3 slots that you can fill. Well, then you dynamically increase, and that one has now 6 slots. So it just depends on the number of available slots or places that you can fill in values for the array. It's not dependent on the actual elements in the array. Um, Jose Manuel Enriquez, hello. Hi, greetings from Mexico. Hi, I appreciate you coming in. It's awesome that we're meeting together, and I appreciate you coming in. Hello. Yeah, Nugs, that'd be great for sure on Discord. If you want to send me that, I take a look at it. Yes, front is not always at index zero because front will, increase as we remove elements, right? So like I said, our front was initially zero here, but we removed elements, so our front becomes the next available placeholder. These values get replaced with none, right? They get filled in by none, and then they eventually, when we wrap back around in this circular queue, we will override elements, right? We will override new elements, E, let's say, for none in that placeholder, right? Yeah, so I think Nugs is right, Mahan, is that assuming that the error comes from the DQ, like we are assuming that, like it does directly say in the problem that that DQ is what's throwing those errors and they're caught and ignored. So the answer to this one is a solid 10. I don't think there is a 10 to 15 because the 5 unsuccessful DQs out of the 10 DQs could happen anywhere, but remember, the principle here is that the front that we've kind of deduced is that the front is equal to the total number of successful DQs as long as the queue is never resized greater than the original capacity. That's kind of like our proposition here. Oh, when you dequeue the front element, the others stay in place. Yes, so when you dequeue an element, you don't remove it from the list, you just replace it with a none value. So then you can override that none when you come back to it circularly in the queue. So we don't want to. So the whole point of circular queues is so we don't have to keep increasing the array over and over and over again. We can just have it set to one fixed value and then re-override those already removed none placeholders and then just keep track of an index as we do that, to determine where the next first is in our, we're dynamically changing the first point in our, our queue. Yeah, so Wing Hong, that's exactly kind of the proposition I kind of have deduced from this is that the front is equal to the number of total successful DQs. As long as the queue was never resized greater, right? Because then that would obviously cause the front to, you wouldn't have those DQs so you can't dynamically change the size, is what I'm trying to say. Sorry if I'm yapping here. Okay, awesome. Seems like everybody seems to be on the same page here. This one was kind of tricky, so let's move on here. How long have we been live here for, you guys? Oh, an hour and a half. Okay, so we only got a little bit longer here. I do have some stuff. My family, we're going to an escape room this evening, and so wish me luck in that. It's supposed to be like in the dark and kind of scary, and it's gonna be fun. We'll give it a try. No, Wing Hong, no worries. This is perfect. We all want to be on the same page here, and I'm glad that we're all getting this together. If you guys are enjoying this kind of format of us working together to solve these problems as a kind of a more open form, environment, please follow along. I love to have you guys here. I've been streaming every day for the past almost 3 weeks. Got the streak going here, so it's feeling real good. Okay, let's go R 6.10 underscore key dot pi. Okay, let's do one more here before we go ahead and call it for today. But I will be back tomorrow, guys. Don't you worry. Okay, so this one says, consider what happens if the loop in the array queue dot underscore resize method at lines 53 and 55 of code fragment 6.7 had been implemented as for k in the range of size. We're going to take the data at index k is equal to old at index k rather than old at index walk. Give a clear explanation of what could go wrong. Okay, let's go back up to that method here. So this is what it's referring to as the resize here. So when we fill up, we assume that cap is greater than or equal to the length of self, the object itself. So cap is the current size of the so we resize the new list to the capacity of greater than or equal to self. So we set old is equal to the current values of data. We set self.data is equal to a new list of none times the capacity. We walk, our walk point is from the front. So for every k value in the range size, we data k is equal to old at walk. So why can't we say k here rather than old walk? That's what we're trying to figure out here, okay? Hmm. Mahan, feel free. Please send me that question on Discord, and I'll give it a go tomorrow. Rather, I've only done one. I've only done the very first beginner elite code problem. I did that one, and I didn't do any other ones because I didn't really focus on leak code because I was trying to learn these concepts first. But maybe doing some leak code could help us, practice these concepts that we've already learned. So yeah, Phil, please send me that question or post it in the Discord, and we can all try it together offline, or maybe tomorrow we can do a little recap over it. So what is the difference here of putting K here rather than walk? Oh, because we are writing. Ah, okay, because we need to keep track of the front for the old, right? Okay, so what's happening here is if we if we bypass the walk, which houses the front of the old queue, we would not accurately. How do you spell accurately? How do you spell accurately? Accurately spelling. I think that's right. Accurately. Okay, we would not accurately capture the front values associated in our old queue when trying to update them, update the new self dot underscore data starting at a front a q dot underscore front equal to 0, right? So if we were to use k here instead of the walk value, see, our walk value saves the front of our old array. So we need to keep that front value so that we can set the front values equal to the because when we dynamically increase the array, we are resetting the front back to index 0. We don't want to keep the front at whatever front it was in the old array. We reset the front back to index 0, so this will save, starting from index 0 through the range of the size. So it's going to go from 0 all the way up to the range, the ending range. We're going to, copy those references from starting at index 0 in the new array to the old array from that first start or from that front position. Hopefully I'm explaining this right. Yes, Nugs, thanks so much for coming in. I really like to hear you come by another time, and I appreciate you spending some time with me today. I'll see you next time. Thank you so much for coming in. Wang Hong says, "Oh, because walk has the old front value, which is meant to push to k. But if you use k, you end up not changing anything." Exactly, right? Because k, right, all these values that precede the walk or the front of the old array will have just none values. So none will be saved for, these values, right? So I'm going to copy this. I'm going to paste it into here to see if it likes my explanation. It's a little bit vague. Your explanation highlights an important issue but could be made clearer and more precise. Yeah, exactly. Here's a refined explanation. If the loop of the array queue dot resize method were implemented as for k in range dot self dot size for this, right, instead of the old walk, the problem arises because walk is used to track the logical order of elements in the queue starting from the front. In the array queue, the queue elements are stored in a circular array, meaning that the front of the queue might not always be at index 0. Yes, the walk variable ensures that the elements are accessed in their correct order, starting from the current front of the queue, old front, and wrapping around to the circular array as necessary. By bypassing walk and using the old k, you would incorrectly assume that the elements in the old array are stored in the sequential order starting at index 0. This assumption would lead to misalignment of the new elements, resulting in a corrupted element or loss of elements. So this is exactly what I was trying to say. So we'll just paste that right there. By bypassing the walk and directly using the old K, you would, or I'm gonna make it a new comment and put it there. I'll keep my original one, and then I'll put GPD's more refined comment here. But this is exactly what I was saying. But if we bypass the walk, right? If we bypass walk, we would essentially be mismatching those elements because we wouldn't be using the right appropriate front value from the old array. Beautiful. Awesome. Okay. Cool. And then let's see here. How many more do we have? Yeah, we will. This goes on to Dex next. So, um, I do have to. I'm gonna leave here in about a half hour for that escape room that I'm going to with my family. Should be a lot of fun. So I'm gonna call it here for you guys. Again, I usually stream you guys for about 2.5 hours to 3.5 hours every day after my 9 to 5 job. I'm really dedicated to learning this, but right now I'm visiting my family over the holiday break here. I'm still doing these streams just a little bit shorter than my normal times. I'm only doing about an hour and a half to an hour and 45 minutes, but I still wanted to come on here every day to keep the streak alive, to keep my learning going, to keep these concepts fresh, and also just to interact with you guys and keep growing that way, and make sure that we're staying on top of this and everything. So I appreciate you guys joining me for today. I'll be back tomorrow for another hour and a half, hour 45 minutes. But on Sunday, I'll be back home. I'm flying back home on Sunday, and I'll be back in my normal setup, and we'll do a normal 2.5 to 3.5 hour session where we will first start off with our learning here, continue on, probably move on to chapter 7 by then, get into chapter 7, which is about, let's see here, linked lists. So we're really going to start getting into more stuff that LeetCode starts to really grind in, linked lists, all that kind of stuff. So we're going to get into that, come next stream or the stream after. But in those longer sessions, you guys that are new, after I do this learning for the first half, hour and a half, in the back half of the stream, I work on actual projects. So right now we are writing an entire project from scratch called the Small Business Manager, where we are, we have a data structure here of a class that we've created, and we are essentially, managing inventory items for a business. We are converting those items into for sale items and sold items, updating attributes accordingly, having these items save appropriately in files, accessing these elements, being able to override them, update these features if they were incorrectly put, have, date times, use the module date time to track dates. We're converting all of our currencies into cents rather than using floats, because floats have, rounding properties and interact differently on various, software, on various operating systems and stuff. So we were successfully using integers, converting to cents, total cents from dollars, US dollars. So we have this, just to give a quick example, I'll just show you guys what we got so far for this. We work on these projects, implement all the learning that we're doing in algorithms and stuff. Originally for this program, I actually wrote a binary search for this search, but we reconverted our data structure into a simple dictionary where the item numbers were just the key values, so we could access them in constant time rather than in log time using the binary search. So we actually improved our efficiency of this program, and we were able to recognize that, and it just goes to show you that this learning that we are doing in this book is sticking. We are learning this stuff, and we are directly applying it into live projects, and which is what we're supposed to be doing to show that we are knowing we're learning this and we're compounding it. So to give an example, we can press 1 to enter the program. I'll just go to show you the current items in our list. If we go to our inventory, we can find and edit an item. Let's go and do by item number. We can pull up item number 8. As you can see, item number 8 here was successfully pulled up for all its attributes. We can override things like new name. If I press 6 to go back, that'll save that. And as you can see, new name was appropriately added there. If we go ahead and do like a find and transact, or whoops, sorry, wrong button. We haven't implemented that function yet. Let me go back here, run, here. If we go yes, if we go transactions, transact for sale item. As you can see, the date listed infers that an item is listed for sale. So this item 6 has a date listed. So if I press 6 here, we get this error saying that 6 is already for sale. So we're getting there with actually converting these items. And next, what we'll do is we're going to generate reports for conveying like cost of goods across the whole year for various months, for generate income statements, all that kind of stuff that small businesses usually have to pay for through like TurboTax or other TOS services. We can provide for free with this GitHub repo that we're developing for very small businesses, and just reduce that expenditure even greater. And so we're writing this program, for those small businesses, so they don't have to pay for these large programs, and it'll be free, and it'll be cool. So it'll be really awesome. All right, I'm gonna head off here, guys. I will talk to you guys later. I appreciate you guys joining me today. We This was a very successful stream. We did, what was it? 5 problems here. 5 problems of the end of chapter 6. We have about how many more left here? We got 4 more problems, and then we'll move on to chapter 7. So we'll probably start reading chapter 7 tomorrow after we complete a few more of these. And then, as I said, on Sunday, I'll be back for the full stream, 2.5 to 3.5 hours, like I normally do, where we'll work on our projects and keep going. I appreciate you guys joining me. Let me get caught up on the chat here before I go. I've sent 2 of them. The first one can be done in 2-3 minutes. Second one can be challenging. Even the easiest leak code took me forever, okay, awesome. Yeah, so Wing Hong, Mahan, Nugs, Jose, Copter, Sarah, Corey, Kai, Fake, Jay Torres, thanks so much for coming in, you guys. I appreciate you guys joining me today. Big pat on the back for you guys studying with me today. Super awesome. Jay Torres 1800 says, I just graduated with the BS and CS. You're on your way to mastering algorithms. Awesome. That's very supportive feedback, and it's so nice. It goes to show you that we're on the right track here with people that actually have degrees in this. They're saying that we're on the right track. We're not wasting time, and this is awesome. So I'll see you guys tomorrow. Join the Discord and chat with me offline. I can be reached on there offline, and yeah.